Scene script. Have you ever wondered why we see the past and not the present? A question that may seem perplexing at first, but one that opens the door to the fascinating world of perception. Perception, in its simplest form, is the way we interpret the world around us, the way we make sense of what we see, hear, taste, touch, and smell. But today, we're diving into the realm of visual perception and how it's miraculously tied to the present moment. Our eyes, those intricate orbs nestled in our skulls, are more than mere windows to the world. They are complex organs that capture light, convert it into electrical signals, and send these signals to our brain. The brain then weaves these signals into the visual tapestry we perceive as our reality. It's an intricate dance between the eyes and the brain, a ballet of light and perception that allows us to navigate our world. But here's where things get truly intriguing. This dance, this delicate interplay between our eyes and brain, happens in real time. When we see a bird soaring in the sky or a leaf fluttering in the wind, we perceive it happening in the present moment. Our brain processes the information, aligning our perception with what we believe to be our now. Yet there's a twist in this tale. The light we perceive, the light that paints the pictures in our minds, travels at a finite speed. It takes time, albeit a minuscule fraction of a second, for the light reflected from an object to reach our eyes. So when we look at an object, we are seeing it in the position it was in when the light was reflected and reached our eyes. In essence, we are always seeing the past. But our brain, that masterful maestro, updates our visual perception to align with the present. As time advances, the images we see also change to reflect the position of objects in the present moment. But what if I told you that when you look at something, you're actually seeing it as it was in the past, not in the present? To understand this, we first need to grasp the concept of the speed of light. Imagine you're in a super fast car, driving at night. Your headlights illuminate the road ahead, but what you're seeing is not the road as it is right now, but rather the road as it was a fraction of a second ago when the light from your headlights first hit it. This is because light, like your super fast car, travels at a finite speed. The speed of light is one of the fundamental constants of nature. It's like the ultimate speed limit of the universe, and nothing can go faster. It travels at an astonishing speed of approximately 186,000 miles per second. That's fast enough to circle the Earth more than 7 times in just 1 second. When we observe objects, what we're actually seeing is the light that was reflected off those objects and has now reached our eyes. So for instance, when you look at the moon, you're not seeing the moon as it is right now, but as it was about 1.2 seconds ago, which is the time it takes for the light to travel from the moon to your eyes. Now this might seem weird, because when we look around, everything seems to be in the present. That's because light travels so incredibly fast that the delay is usually imperceptible. But the delay is there, however minuscule it may be. Even the light from the sun takes about 8 minutes and 20 seconds to reach us. So if the sun were to suddenly disappear, we wouldn't know about it until over 8 minutes later. In essence, when you're looking at something, you're seeing the light that was reflected by that object and has now reached your eyes. You're seeing a snapshot of the past, however recent it may be. So next time you admire a beautiful sunset or gaze up at the stars, remember that you're actually looking into the past. So, if we're seeing the light that was reflected off objects and has reached our eyes, are we seeing the past? That's a question that might have you scratching your head. Well, let's dive right into it. When we look at an object, what we're actually seeing is the light that was reflected off of that object and has traveled to our eyes. Because light travels at a finite speed, there's a tiny delay between when the light was reflected and when it reaches our eyes. This means that we're seeing the object as it was when the light was reflected, not as it is at the exact moment we see it. Think of it like a cosmic game of tag. The light is it, and it's racing from an object to your eyes. By the time it reaches you, the object has moved on, but you're seeing where it was when the light started its journey. Now let's take this concept and apply it on a grander scale. Consider the stars twinkling in the night sky. These celestial bodies are so far away that the light we see from them has been traveling for years, even centuries. When you gaze up at the night sky, you're seeing the stars not as they are now, but as they were when that light began its journey. If a star is 100 light years away, you're looking 100 years into the past. Our night sky is a time machine in a way, showing us a glimpse into the universe's history. But don't let this make you feel disconnected from the world around you. Yes, in a way we're always seeing the past, but but it's a past that's fractions of a second old. Our visual perception is so quick to update that it feels like we're seeing the present. That's our now. So, next time you're marveling at a beautiful sunset or stargazing on a clear night, remember, you're not just seeing light and color. You're also seeing time, history, and a snapshot of the world as it was, ever so slightly in the past. This means we're always seeing the past, but our visual perception is aligned with the present time, making it our now. But if we're always seeing the past, how do we perceive the present? Well, it's all about the incredible work of our brains. The human brain is a marvel of nature, processing a myriad of information every second, and among its many functions, it's responsible for our perception of time and space. Our brains constantly update our visual perception to align with the present moment, allowing us to interact with the world in real time. Let's imagine you're watching a baseball game. The pitcher throws the ball and you see it soaring through the air. But remember, what you're seeing is the light that was reflected by the ball and reached your eyes. You're seeing the ball where it was a fraction of a second ago, not where it is now. Yet, our brain compensates for this delay, allowing us to perceive the ball's motion as continuous and smooth. Our perception of the present is a dynamic process, changing as time advances. The images we see are constantly updated to reflect the position of objects at the current moment. This is why when you reach out to catch a ball, you're able to grab it where it is, not where it was when the light reflecting off it first reached your eyes. This constant updating of our visual perception is a testament to the intricate complexity of our brains. It's like running an incredibly detailed and accurate simulation of the world in real time, every moment of every day. So, the next time you marvel at a beautiful sunset or gaze at the stars twinkling in the night sky, remember that you're not just witnessing a spectacular visual display. You're experiencing a testament to the power and sophistication of your own mind, its ability to perceive and interpret the world around you. So, even though our vision is related to the past due to the finite speed of light, our visual perception is always updated to the present. This alignment of our perception with the now is what allows us to navigate and interact with the world in real time, making each moment truly ours to experience. So next time you look at the stars, remember you're not just looking at distant celestial bodies, but also gazing into the past. We've journeyed through the intriguing world of perception, delving into the mysteries of how our vision interprets the world around us. We've explored the significance of light's finite speed, and how it shapes our understanding of the world. When we observe objects, what we're truly witnessing is the light that was reflected by these objects and managed to reach our eyes. This means that we're essentially viewing the past, as the position of the objects we see is where they were when the light was reflected. The fascinating part is, despite this slight time lag, we perceive our world in real time. Our brains are remarkably adept at synchronizing our visual perception with the present moment, aligning the past we see with our now. This intricate process allows us to interact with our environment seamlessly, without any noticeable delay. As time marches on, the images we perceive also evolve, mirroring the ever-changing positions of objects in our environment. This is how we experience the world as a dynamic, ever-shifting landscape, even though the light we see is technically rooted in the past. So, while our vision is inherently linked to the past due to the finite speed of light, our brains cleverly bridge the gap between the past and the present. This beautiful blend of light, time, and perception gives us a now that's always refreshed, always current. Remember, this isn't just a scientific phenomenon but a testament to the marvels of human perception. It's a reminder that our everyday experiences are far more complex and extraordinary than they may seem at first glance. Our perception of the present, then, is a fascinating interplay of light, time, and the human brain. It's not just about what we see, but when we see it. See,